Thank you very much. Welcome to Fuel Cycle Technology. We appreciate your interest in this area of nuclear material and separation chemistry. We believe that nuclear chemistry is an integral part of sustainable civil nuclear energy applications, and your research interest and support will continue to strengthen nuclear fuel cycle technology development. Currently, due to various reasons, including the economic of the technology, we in the United States do not practice commercial recycling of nuclear fuel, but we must continue exploring technology options for policymakers to consideration. Again, my name is Stephen Kong, and in the Office of Material and Chemical Technology, aka NE43. I serve as your federal POC point of contact, and will introduce fuel cycle technology solicitation topic FC-1.1 to 1.4 this morning. Before I start, I would like to quickly go over the program that the solicitation topic will eventually support and sponsored by. Next slide, please, to slide number 2. Yeah, thank you. A brief introduction. The material recovery and wasteform development program support early-stage applied R&D activities. For example, we developed advanced fuel recycling technology, which presents significant technical risk and cost uncertainty for industry to invest. Our program mission is to improve resource utilization, reduce waste generation, and limit proliferation risk. For example, the program supports aqueous separation and molten salt chemistry and recycling technologies to maintain critical technical expertise and capabilities at the DOE national laboratories and U.S. universities. The program supports the advanced reactor technology development by producing high-assay, low-enriched uranium, also called HALEU material, for advanced reactor initial demonstration. Lastly, our program developed advanced simplified single-cycle technology targeting high-value use fuel. In this case, we refer to HALEU containing spent fuels. As we know, many of the advanced reactors being developed may use fuel cycles that are significantly different from existing light water reactors. For this advanced systems use solid fuels. Other advanced systems may use liquid fuel, for example, as a molten salt reactor. So we recognize that advanced reactor concept focus on sustainability and resource utilization. Thus, each of these advanced reactors may require specific supported fuel cycles. So as this diverse reactor technology concept being further demonstrated by our nuclear energy office, our material recovery and wasteform program will continue to evaluate their associated fuel cycle needs and requirements. Next slide, please. Yeah, this shows within our program there are 6 major thrust areas. So we highlight in the left-hand side the blue areas. The first one is the aqueous fuel cycle chemistry technology. So NE supports fundamental nuclear fuel cycle aqueous processing and chemistry to maintain critical research core competencies. Specifically, programs seek to better understand chemical speciation and complexation mechanisms to improve actinide separation mechanisms. This subprogram supports R&D in radiolysis and the radiation chemistry, and to evaluate the ligand stability during the solvent extraction process. We also study radiation-induced actinide redox chemistry and online monitoring for process control. This topic in aqueous phase using solvent extraction method for nuclear separation is directly related to the solicitation FC-1.2 you will see later on. The second area is focused on molten salt chemistry and processing. In addition to pyroprocessing technology development, this subprogram supports activity using advanced instrumentation and methods to understand molten salt structure, dynamic, and their relationship with salt chemistry properties. The goal for this subprogram is to enable predicting and optimizing salt thermophysical properties. So as we all know that molten salt can not only be used as electrolyte in pyroprocessing, we can also use it for separation and others like a coolant and a solvent for molten salt. Most importantly, we can also use molten salt for energy storage. So this molten salt area is the focus of Solicitation FC-1.3 and 1.4. You will see shortly. The third area is cross-cutting technology, including off-gas capture and immortalization, and also for advanced wasteform and development. So the goal for this cross-cutting area is to enhance the waste loading, durability, and eventually lead to technology cost reduction. So tomorrow afternoon, we will cover this area in Solicitation FC-1.5 and 1.6. The fourth area is joint fuel cycle study, which is a collaboration with South Korea. So the next one is the hybrid Zersex. So hybrid Zersex use gas-phase chlorination method to extract zirconium or aluminum, followed by a polishing process to purify the final product. So vapor phase separation has an important advantage, which can significantly reduce the liquid waste generated during the process. For example, we don't need a strong acid to dissolve all these materials. A gas phase chlorination agent can directly convert solid zirconium cladding material to zirconium tetrachloride, for example. So in this case, we use hydrochlorination methods to remove the cladding material. So we can eliminate the dissolution process. In this case, it's reduced a lot of the waste volume. So this is related to the solicitation topic 1.1. So it's more like a vapor phase extraction. We will talk about that shortly later. The last one is EBR2 acceleration. So in this case, we are using pyroprocessing to accelerate the production of HALEU material using the EBR2 fields. All right, next slide, please. The slide number, yes, 3. Thank you. This slide shows DOE National Laboratory that the program currently supports. You can see the 5 the red dots are the national laboratories. So of course, Idaho Labs in the in the middle part is our nuclear laboratory, and Idaho heavily involved in all of our thrust area we mentioned previously. So we also have some other activity, of course, at other laboratories, as you can see here. And most importantly for this community is we currently support about 3 dozen of universities, so to conduct research in our areas. The goal for university programs are to seek innovative research concepts and to train our next generation of nuclear chemists or chemical engineers. In other words, we are trying to address nuclear workforce pipeline issues. So that's the purpose of NEOP solicitation. So please go to the next slide, please. Oh, thank you. So here's the 6th solicitation topic under material recovery and waste form. Our current plans to issue 6 topics as listed here, but depending on the final appropriation and the funding availability, as mentioned previously by Drew in previous presentation, we will decide later on, depending on funding and budget available. So we will decide how to proceed further. So next slide, please. Go to slide 6. Yes, please. All right. This is the FC-1.1, as I mentioned early on, is the so-called gas phase separation. In this case, we are targeting chemical decladding or vapor phase reprocessing technology. Specifically, we seek to support innovative gas phase separation such as halogenation, including advanced chlorination, hydrochlorination, sulfur coordination digestion methods, and fluoride volatility processing. And also, we are interested in advanced oxidation technology to separate off-gas elements such as tritium and iodine. As I said, I'm your POC point of contact at headquarters. The laboratory point of contact is Ken Marston. So you can see Ken is also our technical director, National Technical NTD. So next slide, please. Slide 7. Okay, this is FC-1.2. So in this area, we target the simplified solvent extraction in aqueous separation process. So currently, we all know that the Purex is the king. So in the commercial practice, including the France and the England, they are using Purex process like La Hague and other process. Even the Japanese are using a modified Purex process. But we try to develop the simplified process. Can we simplify the Purex? Purex currently at least involves 3 cycles. Can we just simplify it with 1 or 2 cycles? For example, the CEA, our French colleagues, they are working from Purex to Ganex, group separation. They try to simplify that. But we want to go beyond Ganex to even more simpler systems in this case. So our target, specifically, we are seeking innovative approach to better understand and enable simplified aqueous separation technology. So example include novel organic ligand design and the synthesis. And we also want to look into metal ligand complexation and the coordination chemistries, radiolysis and complexant and the radiation stabilities, and the computation modeling and solvent extraction phenomena. So again, POC, the same POC and the lab and the federal people. Okay, next slide, please go to slide number 8. Oh, thank you. So this FC-1.3 focus on computational approaches in developing innovative modeling and simulation capabilities. The goal is to use various model and advanced simulation, including machine learning, to predict thermophysical and transport property of molten salt. Example including applying molecular dynamic simulation to predict thermophysical and transport properties, and build multi-component models for prediction of phase diagrams, or develop an advanced model to guide experimental efforts to manipulate molten salt thermophysical and chemical properties. So next slide, please, the last slide. Thank you. This FC-1.4 is targeting experimentalists who utilize advanced characterization tools and the instrumentation methods to determine salt molecular structure and property relationship. The objective is to experimentally validate the local structure and bonding of molten salt and their relationship with thermophysical and thermochemical properties. So some examples I list here are determining salt molecular structure using scattering and spectroscopy methods, develop novel electrochemistry and the methods for in situ monitoring and predicting modeling. And the last one is developing a molten salt optical basicity scale to determine the corrosivity and solubility of actinides. Again, the POC and at federal and the laboratory side are the same, Ken Marston and myself. So that concludes my presentation. Thank you for your attention and to joining us today. I'll be happy to entertain questions if there's any.
Okay, Stephen, I will begin sharing questions, but first, for the audience, if you have questions, you're welcome to type them into the Q&A feature of this webinar. And for this particular area, it would be helpful if you would identify the work scope for which you're addressing your questions, since there are several work scopes here. So, Stephen, I will begin with the first question. Could you please elaborate? Could you please elaborate a bit more on which types of federally owned nuclear fuels should be targeted for hybrid, Zirkex, RD&D?
Our current targeting materials are like research reactors, or some surplus federally owned like a naval reactor or other fuels with with a lot of uranium in there.
Okay, next question. For FC-1.3, could experimental validation of models developed by the group be within the scope of the work scope, or would this be better in FC-1.4?
It doesn't matter. If you combine both, that's welcome as very much. So go either way. I would, if you are focused, depends on what's your focus. If your focus is on experimental validation, please go to 1.4. If your focus is on computation modeling or simulation, please go to 1.3. If you do both equally, then you can go either way. I would suggest 1.4 because 1.4 is a 3-year 600K. That's probably more comprehensive if you are doing experimental work.
Thank you, Stephen. The next question, also for FC 1.3 and 1.4, would the measurement of thermophysical properties be limited to viscosity and heat capacity, or is thermal conductivity of interest too?
Absolutely. We are looking for innovative ideas for all the properties. If you can make sure you can help us to better understand the thermochemical and physical properties and in any areas, and then correlated to structure. We are not interested in just measurement. We are interested in methodology and how to creative new ideas of understand fundamental science behind the thermochemical properties, not just measuring thermal properties.
Okay, next question. This also is for FC 1.3. Are computational methods utilizing machine learning instead of AI/MD acceptable as well?
Absolutely. Why not? We welcome all innovative ideas.
Thank you. For FC 1.2, is there any interest in non-aqueous separation chemistry? If not for this focus, what about others?
So our focus is aqueous solvent extraction, aqueous solvent extraction. If you are interested in non-aqueous separation, go to FC-1.1. That's we call the vapor phase, gas phase separation. Unless you have solid separation, I'm not aware of any. So in that case, I don't know. That's not the solicitation topic.
Thank you, Stephen. The next question is also for FC 1.2. You refer only to SX. Is IX and immobilized ligands not relevant to this RFP?
What do you mean by IX? I'm not sure. Can you repeat the question again?
Yeah, the question is you refer only to SX. Ion exchange. Okay, so the IX is referring to ion exchange. So the question then is ion exchange and immobilized ligands not relevant to this RFP?
Ion exchange. Sure, ion exchange can be part of that one. I don't recall we mentioned ion exchange explicitly here. So maybe I will read so where did you get the ion exchange idea? That's good. We can do that in ion exchange. That's sure. That can be part of that. That's part of separate extraction process.
Okay,
but here
next.
we are talking about ligand exchange. We are targeting advanced ligand, in this case, trying to simplify the process. Thank
you, Stephen. The next question is for FC 1.1. Are modeling and simulation of gas phase transport of interest in FC 1.1, or FC 1.1 is an experimental effort only?
So modeling is welcome. I don't think we should restrict to experimental only. Yes, of course. If that's the question, right?
Okay. That is the remainder of the questions.